Morning, everyone. My name is Nitin Mehta. Vinayak has already done the introductions. I'm going to skip that. Let's jump right into the presentation. As Vinayak mentioned, we'll talk about open source databases. We'll talk about the database service that's available on Azure. Um, Quick agenda. We'll talk about some things which are coming up, some services which are specific to specific use cases and how and when you should use one versus another. Then we'll quickly have a peek into use cases, but we'll not dig deeper into that. The reason is I'm fairly sure that you guys have better understanding of your use cases. So instead of talking about specific use cases, we are going to talk about some sample architecture that is has been put around on Azure using the open source database services. And then third topic we'll pick up is some of the basic optimization points that specifically for MySQL that users do look at are important for your basic performance optimizations. And uh, like Vinayak mentioned, we'll try to take as many questions as possible during the presentation, as well as at the end if time permits. So with that, the first topic is open source databases on Azure. So these are the database services. The first one is MySQL and MariaDB, of course, which have quite a big following. A large number of developers build on MySQL. Some of the developers are starting to move over to MariaDB, and then depending on your personal choice, MySQL and MariaDB still remain quite important and popular databases, right? Why? Because I mean, I'll get into why, but 9 out of the top 10 websites worldwide are powered by MySQL. And MariaDB in particular has seen quite, tremendous growth in popularity in last 4 or 5 years now, actually, not just in last 3 years. The key reasons behind the popularity are, the vast community support that's available around these databases, right? There is a rich ecosystem of tools which allows you to work very well on these databases. And of course, as a general thing for all the open source databases, these offer lower TCO because there is no or very few licensing fee to be paid. MySQL in specific, in fact, MySQL and MariaDB again both are very lightweight to run, right? Low resource consumption means a lot of organizations also use these databases as their choice of embedded databases. These are optimized for OLTP websites. Again, very, very popular and a key part of LAMP stack. So if you have heard of LAMP stack, it includes Linux, Apache, MySQL or MariaDB, and Perl or Python, right? Or PHP for that matter, actually. So it's a stack that's been in use for quite a long time now. I think definitely for last couple of decades, I would say. Last 15 to 20 years have seen a lot of development on this stack. Now, next is why PostgreSQL. It's easily one of the most loved databases and a wanted one. Um, it's been database management system of the year chosen by DB Engines, which is a third-party ranking system, uses some really interesting ways to calculate these rankings. And not just 17 and 18, I think it's been DBMS of the year for year 2020 as well. So quite popular. And again, why is it popular? It's one point, of course, is being an open source. Just like MySQL and MariaDB also has a large developer community. If not bigger than MySQL, I would say probably equally as big as MySQL. Right? There are people who uh, there are some hardcore fans of MySQL versus PostgreSQL. So there are some choices that you make depending on what kind of application you are developing. It comes with proven resilience and has a lot of stability as well as a very rich feature set. So MySQL, which is quite popular for web applications, for simple OLTP applications. PostgreSQL, on the other hand, is good for solving multitude of use cases. It is used for uh, anything like ERP to data warehousing and everything in between. So with the feature set that PostgreSQL provides, it's quite a general purpose database and very widely used. Now, what does Azure bring around these databases, right? So the first point is we are using Microsoft uses open source databases. So there is no lock-in. It's the same database that you can use elsewhere as long as you are using the open source application. We do use some of the extensions that I'll talk about, but more importantly, what the database as a service provides is features around these capabilities that database as a product themselves bring up, right? Uh, Features in terms of scalability, how easily with a click of a button you can scale up, scale out, and so on. Compliance, which is on mind of almost every CIO today. So a lot of security and compliance certifications that we bring up for these databases. Global reach, of course, Azure has highest number of data centers across the globe, right? And that means you have the choice to use these open source database services across the globe. Within India, we have, of course, three regions, and these database services are available in all three regions, right? Ecosystem integration. So whether you're using Azure AD or you're using, Azure Data Lake Store and many other services, these databases have been made, or the database services have been made and built up from ground up to work with all the ecosystem that Azure has in and around databases. High availability, of course, is taken care of by the platform, so you don't need to worry about. But then we are building on top of that, and I'll talk more on that. Um, this is a quick comparison on how your on-premise database versus platform as a service or database as a service and everything in between looks like. What are the responsibilities you as a user and Microsoft as a solution provider have, right? I would say Azure takes the admin out of it, but then the real important factor is that the admin is now, has more time to skill up and, perform more important tasks, right? For example, it could be things about optimizations, which looking at your database performance and see what are the options for optimizations. Could be how best to secure your data. So basically you skill up, you take bigger responsibilities instead of doing the the same task over and over again, right? So some of the key important tasks, but which are the basis for any database, are taken care of by the service itself, right? For example, high availability, OS provisioning, patching, setting up replication, bringing up hardware, making the virtualization to run your VMs, all of those things you don't have to worry about, or backups, all of those are taken care of by service. You have options to make use of high availability options. You have options to focus on security, but uh, the actual implementation is all taken care of by service. On top of that, there are some intelligent features in area of security and performance, which Microsoft has built and provides, uh, as well as it works on SQL Server. It works similarly for open source databases also, right? Application and data, of course, that remains a responsibility of users, of customers. They manage their application, you manage your data. You are responsible for utilizing the exact security features that are available and making sure that your environment is as safe and secure as possible. Now, next is, what are the deployment options for MySQL and PostgreSQL? Okay, so single server, which is currently available, generally available service. It's enterprise ready, fully managed with community versions. There is a lot of scale, lot of high availability features, everything that you would require from an enterprise database, everything already built in. uh, Replication, you want to create replicas outside of region, all of that is currently part of single server. The next offering specific to PostgreSQL is hyperscale. So this is thanks to Citus as an extension, which still remains open source. So you can use Citus for, you may have heard about some technologies called sharding and so on, right? Earlier, yeah, sorry, is that a question? Yeah, so sharding as a concept is not new. For more than a decade, applications have been using sharding, but it was the logic you would usually sit with the application. So what Citus does is it brings that logic into database, and for your application, it could be quite transparent how your data is scaled out. You can use tens of database servers, or maybe in sometimes hundreds of database servers, which will store your data. And data is sharded so that you get optimal performance from database as a whole. Application talks to single node, but then your data is sharded across multiple nodes. So this is something that we have incorporated into hyperscale as an offering. I'll talk a little bit more about it in the course of the presentation. Um, the next service, which is currently in public preview, is flexible server. It's more of an evolution of single server, right? So there have been some learning, some things that customers have asked for, more control that they wanted. And with all those learnings, we have, built this platform from scratch once again. It changes everything, from OS to how your connections come into the database and things like that. So a lot of things, lot of changes in flexible server. It's available for testing today. It's available in large number of regions already, and soon to be GA. The last one is Arc enabled hyperscale. So Azure Arc is a service wherein you get this central management and monitoring layer on Azure, and your infrastructure actually could be anywhere. It could be on-prem, could be on Azure, could be on any other cloud. Using Azure Arc, you can start managing that right out of single pane of glass on Azure. So we are extending that to include PostgreSQL hyperscale. So if you have Citus data implementation on-prem or on any other cloud today, and you want it to be managed with your other implementations on Azure, you can do that. Arc allows that. Um, yeah. With that, let's quickly jump into the new offering, flexible server, as I was talking about. So why flexible server, right? Single server, which has been, like I said, available for quite some time. I think it GA'd way back in 2018, and it was built for everything that you could ask for from an enterprise database. Of course, being served by an open source database, right? It has all of those features, but then uh, there were some trade-offs and some of the things that um, users over a period of time have identified could be sometimes bottlenecks or maybe just more control that users wanted. So some facts around single server, it, like I said, GA'd in 2018. Um, uh, you know, Everything else, I think I've spoken about this scalability, read replicas, all of that. Um, Now, the challenge number one with single server was, for some of the applications, it's not something that affects everything, of course, but some of the applications which are highly dependent on uh, latency, right? Uh, Single server today has a little bit of higher latency. The reason for that is how this is deployed, right? So you don't have a choice. Before I talk about that, you understand there are regions, and then there are availability zones within region. So, for example, let's say East US is one region. There could be two, three availability zones within the region, which means there are different data centers spread across the region. Uh, and with single server, you did not have an option or a visibility into which data center actually is going to come up with your service when you provision it, right? Which meant that your application could be in one data center and your database server could actually come up in a different data center, unnecessarily adding to some latency. While it could be very, very small, it could be like maybe a difference of 1 millisecond, but still, it probably is unnecessary latency, right? Then the second one was the connection redirection was through gateways. So Azure uses these connection gateways, and it was something that we also use for Azure SQL databases. But we've seen that this also is adding to some of the latency. So this is something that flexible server to start with, you know, offers to take care of, right? Now you have option of clubbing or choosing which availability zone your service comes up in. And we have also gotten rid of the gateway, so your connection is directly to database server now, right? In fact, we have added another key change to this, and probably will be something that gets covered in next part. Yeah. So monthly maintenance window, that was again a challenge faced by some of the users where, while there is advanced notification of 70 hours and there is uh, a defined window when the maintenance will be done on your servers. The actual maintenance only happens like within minutes, like 2 to 5 minutes probably, but it's something that you did not have control on. So with single server, that is still the case, right? You don't decide when that maintenance window can be. So that's something that is again a learning. You don't have control, and this is what we have improved. We have reduced the maintenance window from 15 hours to 10 hours, and within that, now you can choose a specific time period, in fact, per server. So every server that you provision, you can choose this is the time window that you want this server to undergo any maintenance, right? So that's something that's been improved. That was a learning, and we have incorporated that in flexible server. Now the next one was connections. So one was connections were coming in from gateways and two gateways, in fact, not directly to database servers. And as a sort of side effect of that, connection always required username at server name, right? So that gateway could actually redirect it to correct database server. But also because of gateways, establishing a new connection was slightly more expensive. There were hard limits on number of connections and so on, right? So there were learnings again because of user feedback. You wanted the at the rate server name part removed so that it has effect on how your high availability works as well. But more important than that, it reduces time to establish new connections, right? Um, with the database servers, it's been a best practice recommendation to use connection pooling, because if you look at a simple transaction, a large portion of that time taken to perform the transaction is actually used in opening and closing connections, right? But if you use connection poolers, you can actually reduce that by a lot because your connection is available, it is reusable, and hence there's no need to open and close a connection every time you do a small transaction, right? Again, a learning, something that we have sort of incorporated within the server in our flexible server offering. We'll look at that very quickly in few minutes. Um, then the next one is AZ, like I said, availability zone resilient HA. So uh, what could happen is that, let's say one of the data center goes down for some unforeseen reasons, right? Maybe there is a very long power outage. Now the high availability earlier with single server, in fact, um, does not guarantee that the VM that has to come up or the storage that is being maintained will be outside of data center, because there was no way for the infrastructure to really be sure that this server comes up in a particular availability zone. And hence, the failure of one AZ availability zone could lead to downtime, right? Again, with AZ resilient HA, now you can choose in flexible server, one of your, the primary server comes up, let's say in zone one, the other node comes up in zone two, and so on. So if one availability zone goes down, you don't actually have a downtime, and you don't need to, migrate or move to a different region altogether if it is just about one availability zone that goes down, right? Uh, okay, I will quickly skip that. So how is the flexible server architecture? Now there is, like I said, region, let's say East US, and then there are multiple availability zones. These are data centers with independent power, independent cooling, independent, buildings, and of course servers, racks, and everything inside those buildings. Usually for DR, we recommend using a different region altogether. So let's assume it's West US too. But what's more important from flexible server architecture point of view is what happens within the availability zone. So like I was saying, now you have capability to choose which availability zone your service comes up in. And you can ensure that your applications are sitting in the same availability zone. So you get rid of all the additional latency that could be there. And so that's one thing that's taken care of. And then backup storage, which is in that availability zone, will be replicated over to a different region for your DR scenarios, right? Now, in zone redundant HA architecture, your databases are synchronously replicated to a different availability zone altogether, which ensures that you won't lose any data, right? In case of a data center going down. Other things that have been added are like smart defaults. Now, while you create the service, you have an option of choosing, specifying what kind of service it's going to be. Are you provisioning it for development, production, small size, large size, and so on? So it will have some smart default choices for you. Um, so we have come up with a new SKU called burstable. What it does is it gives you a very low cost environment for 1 to 2 core uh, instances. And what really happens is, depending on your utilization, it would sort of scale up and down, and you'll get charged basis the usage that you have. But of course, the performance could take a bit of hit because it's not um, it's not dedicatedly running for you. Let's say if you choose 2 core burstable SKU, you are not actually going to get a dedicated 2 core VM that would always process your request. So there is uh, cost implication as well as performance implication for this. The second optimization that we have done is, now you have option to pause or stop the server. So when not in use, you can simply stop. So you don't pay for compute, you will only be charged for the storage. This becomes available again in flexible server. This I spoke about. Now you can control your planned maintenance. You can schedule the maintenance per server. So you could have, depending on what applications you are running and what is the cyclic nature of those applications, you can choose different scheduled maintenance window for your servers. Downtime for actual maintenance will be less than 60 seconds, and maintenance window that you choose will be a 1 hour window. So during that 1 hour, the server could experience downtime of up to 1 minute during that period, right? Of course, you'll get advanced notifications when the maintenance is actually going to happen. With the service, uh, when it comes to network isolation, you have, of course, two options. There is public access that you can configure for your service. It can be restricted by firewall. It will be restricted by firewall. So unless you whitelist an IP address, it's not available to be accessed from outside world. And then you just add the client list, whichever application server or maybe an interactive client will access this database. The other option is to choose private access, which incorporates or works with virtual networks. So you'll have Azure Virtual Network created for your environment, and then when you create or provision the service, you can make this service part of that VNet, right? Any clients that need to access this service should be part of that VNet, or you can, of course, have VNet peering also. SSL is enabled by default, right? So these are some of the things that we have done. Network isolation with VNet integration to give you better control and so on. Zone redundant high availability, fast failover. Like I said, you could have that uh, synchronous replication between different availability zones, guaranteeing zero data loss, right? And with that, you have the option, or I mean, facility or feature to co-locate your application and database in the same zone. When it comes to developer experience, of course, it becomes simpler now. For example, something as small a change as getting rid of server name in your connection string. Now you can use the same username to connect to any database, whether it is production or your test database or development database. So that's something that you don't have to change in your application when you move from one environment to another, right? Um, Easy cost optimizations, of course, with stop and start feature in your database and bustable skew, right? Now the quick question is when to use which service. So this is a quick cheat sheet on which you can use to decide which service you want to use. Of course, the primary thing today is flexible server currently still is in preview. So you can use it for testing, but not recommend it for your production environments. That's the foremost important thing that you should keep in mind. But beyond that, there are few things like the database versions that we are supporting and going to support. So anything, for example, MySQL 8 onwards will only come up in flexible server. Uh, PostgreSQL single server today supports from 9.5 to 11, but anything beyond 11 will only come up in flexible server. High availability, there is built-in HA in both, but then there is zone redundant high availability, which is only available in flexible server, right? Start and stop feature, uh, other things that will that are planned, customer managed key for encryption. So if you want to encrypt your data on disk, it happens by default in any data store on Azure, right? But it happens through service managed keys. Now sometimes there are requirements where users and customers want to manage it with their own keys, which means you can create and store those keys in Azure Key Vault and use those keys to ensure that the encryption happens using those keys. So it's available in single server today, but coming up in flexible server quite soon. Same for cross-region replicas. As of today, you can only have replicas and flexible server within the same region, but outside of region for your DR scenarios, it's coming up. SLA, of course, once the service becomes GA, there will be SLA. While it is still in preview, you don't get an SLA. But important thing is 99.99 or 4 nines of SLA is guaranteed out of the box for all of these open source databases, which is I think quite a unique feature that Azure offers, right? You don't need to spend on a second server today to get 4 nines of HA. Okay. Before we jump into the next topic of hyperscale, I think we can take a pause and address any questions that are there. Vinayak, do you see any questions that we want to respond to?
No, we don't have any questions as of now. We can go ahead and start with the next section.
Okay, thank you, Vinayak. So let's continue then. And just a reminder, if you have any questions, please drop those in your chat. And Vinayak is helping us with the answers and anything additional that you want to be talked about, we can take up during and after the session, right? So please keep those questions coming if you have any. Next topic is PostgreSQL hyperscale. So what is it? How does it work? We'll look at it in brief. What are the features and so on. So before I jump into this, while I already mentioned briefly about it, it uses Citus, which has been an open source extension available provided by Citus Data, uh, which has now been built in into the service. And what that means is that database itself, PostgreSQL itself, as well as the capability to shard the data in PostgreSQL, both are still open source and sort of extension which is available to community. So you don't get any lock-in with Azure when you use this. It's an important thing because It's not something that is developed specifically for Azure, right? Now, what is it and how does it work? So briefly, you have a managed service in Azure which runs Citus extension, which in turn manages the cluster of multiple PostgreSQL database instances, right? Uh, so when you provision it, you would say this is my contributor node, and these are sorry, coordinator node, and then these are my worker nodes. How many, what capability or rather capacity these nodes have is something that you can choose. For example, 8 core, 64 GB RAM, and so on. But beyond that, the management of this, the replication of data, or sharding of data is all taken care of by the service. So you can scale out that compute or scale, in fact, out or in that compute horizontally at any time that you feel comfortable or you see the need. In fact, as a new thing, we have also started offering a basic tier for hyperscale, wherein you can start with this architecture even with single node. What that means is, let's say, as a startup, you are going to be at a particular scale in next 6 months. So you want to design your applications for that. But today you don't want to use, say, 4 nodes, because today you don't have that kind of scale or load on your application. So that basic tier allows you to start with hyperscale, with Citus data extension, with distributed data. But all of those distributions or shards remain on single server. So you only pay for one node, but you are ready for scale out as and when required, right? Then it distributes data and queries, of course. Like I said, your application still talks to just one node, right? And everything else is taken care of by Citus. And the end result is you get superior performance. So there are multiple use cases for this. You have, let's say, you are catering to, you're serving a software as an application where you are, catering to 10, 15, 20 different users of yours. When I say users, maybe those are deployments for specific customers who would then have 100 end users or 1,000 end users or million end users, right? But software as a service, which where you have this logical distribution of data across, let's say, with customer ID being the distribution key. It makes it very easy. Your data is distributed across nodes. There is no two customers' data sitting together on single node. So every node is serving a specific customer. So those are some use cases which see a lot of utilization on hyperscale. But that's not the only case. I mean, for some of these scenarios where you are trying to do some online analytics as well as OLTP, right? For those use cases, also hyperscale makes a lot of sense. So how does it really work? Okay. Like you said, your application talks to just one node, which is coordinator node. And when you create a table, you would say, this is my uh, column, which is going to be used, or the key, which is going to be used to shard this table. So you would say create table, and then you would execute a stored procedure called create distributed table, wherein you would supply table name and the column name as the parameters. And then depending on how many worker nodes you have created, it would, of course, generate hash values for all the uh, column values inside company ID, for example, in this case. And depending on how many worker nodes you have, the data will be distributed among those worker nodes, right? This happens automatically. All you have to do is create table and uh, make sure you say that I want this table to be distributed using this particular stored procedure. Um, when you query the data, you don't have to worry about where your data actually exists, which worker node is serving that data. All you would say is, I want this particular query to be served. That query goes to coordinator node, and coordinator node ensures that it distributes that query across the cluster. Um, all the worker nodes run those queries, or the worker nodes which are required to run that query. It's not necessary that it will go to all the worker nodes, depending on, I think I have that example here. Yeah. So since coordinator node has the metadata, when you are doing a point select, it doesn't necessarily send it to all the worker nodes. It would know which worker node is capable of serving that data. So so it does all that optimization underneath, under the hood, right? You don't need to worry about any of those things. Um, of course, okay. This is transaction. So if when you make transactions, my bad. When you make transactions, right, and uh, what I mean by transaction is it's not just one statement. So it's not just one update statement in this example. There are multiple update statements which are part of a transaction. So when you do that, it automatically does the multi level commit, right? So it ensures that all the worker nodes have uh, executed the transaction before the response is sent back to the client, right? So so basically the extension and the coordinator node take care of all of that. Now, sometimes the question comes up, how far can this really scale? So there are some case studies which you can find on this particular URL as well. But I would start with one of our own, which is at Microsoft. Patch management for Windows services uses Citus, right? You can assume, I mean, you can imagine really the number of devices which are running Windows. Okay. So all of that data is being maintained in Citus. It's a petabyte scale data which with response times of like less than a second, 0.2 seconds for 75% of queries. So that is the kind of scale that Citus can achieve. Uh, it's just one of the use cases which we started using it for, but then there are multiple customers which are using Citus today and hyperscale today. And petabyte scale is easily achievable. Billions of rows ingested per day is easily achievable. This is all happening as we speak today, right? So that's a scale that it is working at. Um, okay, let's see anything I missed. Hyperscale has started supporting PostgreSQL 12 and 3. Citus 10, which is the newest version of the extension, is also incorporated in Hyperscale, I think starting last month itself. It now includes columnar compression. Uh, Read replicas, I think I spoke about that. Manage PG bouncer, yes. So this is something that we have incorporated into the service. So you get PG bouncer for your connection pools, both in hyperscale as well as coming up in flexible server. Basic tier, as I spoke about, currently in preview, but you can get started for your test environments, etc., where you want to have a distributed environment, but not necessarily you want to start with multiple worker nodes. So you can start with basic tier. You'll get the same familiar features that you want your application to work with, but at a very low cost. Okay. Next is use cases. Let's cover it very, very quickly. I won't really go into use cases specifically, but more or less focus on some of the sample architectures which have been put up on Azure using some of these open source database services. Of course, I don't need to tell you about use case. Again, you're probably, you know, you exist because you have a use case that you are trying to solve, right? And that's your IP, of course. So whether these are e-commerce applications or CMS or document management system and whatnot. There are multiple services, of course, in and around open source databases. So some of them clubbing Redis, which is again a platform service available on Azure. Uh, we have we are currently actually working with a number of startups where we are helping them scale with Azure Kubernetes service and MySQL or PostgreSQL and so on. So your CMS, your e-commerce platform, like I was earlier saying, whether it is using Magento or something else, or maybe something you have come up as your own development. So um, multiple, of course, services that make use of open source databases. A large number of these applications out of the box support open source databases only. So, for example, if I speak about Drupal, I think at least few years ago, when I used to work more with only with open source databases. I remember Drupal did not support any other database other than MySQL at all. So basically, the idea of saying is all of these services work very well on Azure using open source database services, and not just that. Whether you are running containers, you are running you need a caching layer in Redis, you need app service running your particular workload where you don't want to manage your VMs, you just want to make use of an app service, which is again a platform service. All of that works really well together and gives you, great experience along with uh, databases, right? So let me see if we missed anything here. Fully managed community database. I think the important keyword here is community. I spoke about that earlier. There are no changes to these databases, as in no closed source changes. Everything is open source that we have picked up and are using. There is built-in high availability, intelligent performance that you can make use of. Security and compliance. Azure offers, highest number of regulatory compliance certifications for all the data stores and other services. And of course, integration with Azure ecosystem, whether it is for the app services, for containerized environment, for Key Vault to manage your encryption, data factory, Azure Data Factory, where which can be used to, move data around. If you want to do ETL, you want to load data from other sources into these databases, or from these databases into a data warehouse of your choice to do analytics on top of that. ADF works really well with all of these open source databases. Um, Spark on Azure, whether it is in Databricks or Synapse, connects to open source databases using Azure AD and so on. So the overall integration with Azure ecosystem is superb. Anything and everything that you want to use on Azure probably integrates very well with these open source database services. Okay, so I think I take another pause here to see if there are any questions before we jump into some of the best practices, some of the optimizations that we are going to talk about. Anything, Vinayak, do we have anything that you want to address before we move forward?
Nitin, there are no questions, but I think the webinar has been pretty comprehensive, right? Because I think most of the likely questions are getting answered, whether it's in the use case or in terms of optimization. So let's
Yeah.
move to the optimization, and then we'll take any questions if there are.
Sounds good. Thank you, Vinayak. I'm trying to cover as much as possible. So, yeah, hopefully your questions are answered. But if not, Please feel free to drop any of them. So, okay, some of the best practices. These are general best practices. Nothing very specific to only open source databases or only databases as service on Azure. For example, the number one being retry on transient faults. These faults are possible with anything and everything, right? For example, let's say so there are timeouts at the server side. So what is possible is, let's say you have a connection open from your application to database, uh, and if you are not doing any keep alive sort of um, uh, transactions with your database, when a certain timeout is achieved, your database might end up dropping that connection. And when you send a transaction to this database using that same connection, that since it is maintained by application doesn't know that it has been dropped by database, and it happens with any and every database again. So if that happens, you would receive an error. But the important part is to expect and retry your application, because you have a connection handler, right? So default practice with application, or the default behavior would be to just assume that the transaction will go through because you have a connection handler. But since that connection does not exist at the database layer anymore, you receive an error. So good practice is to expect that and to build a retry logic in your application, right? Uh, Second one is connection pooling itself. As I spoke earlier, right? It's for simple transactions, more than 50-60% of the time could be taken up by for opening and closing a connection, right? So if you can avoid that, that'd be great. You would have probably 75% of time taken to execute a transaction reduced because you already have that connection open. And how do you do that? It is with connection pooling. Now it could be at the application layer, or it could be very with specific connection pools, right? For example, for MySQL, you have things like proxy SQL. For PostgreSQL, you have things like BG Bouncer and so on, right? So use those. Um, Third is configure the right size for your containers or for your VMs and so on, right? It's important because then I mean, you can basically, for example, if I look at Azure Kubernetes service, you can have those rules set up where, if the consumption is beyond this percentage, uh, scale up or scale out this way. So if you have it right size, it becomes much easier to work with those things. Then fourth, of course, again, a no-brainer, secure it with VNet integration. So, generally speaking, your connections should not be coming over public interface. Try to avoid that as much as possible, right? At least the communication to your database should not happen over public interface. Try to avoid that. Make sure that your applications and databases talk over a virtual network in a secure environment over SSL and so on, right? While the service uh, has SSL enabled by default, it's possible to disable it. Do not do that unless you have a very strong reason to do it, right? So uh, yeah, this I spoke about retry logic. Uh, Almost all the applications, rather programming languages, support functions to do this. It's just that by default, sometimes we don't think of using that. So, for example, here you see, it's very easy to use enable retry on failure. But if you don't make use of such functionality, it's really our responsibility, right? Next one, connection pooling that I spoke about. Uh, how do you connect to your database when you if your application is going to open a connection with the database every time it has to execute uh, a transaction, like I said, there'll be a lot of overhead. But if you use something like a connection pool, you know, Azure offers this PG bouncer as a sidecar, right? So every pod in your container or Kubernetes environment that you are running with your application, every pod can have a PG bouncer sidecar enabled, right? Which makes it easy for your application to keep the connections open with these databases, right? So when you connect, you already possibly there's high chance that connection already exists, right? Uh, Container sizing, okay, depends on what is it that you are running on those containers. Accordingly, you should size that properly. Won't go into details of that because different kind of applications could be running on that. Now, after the best practices, let's talk about uh, specific to MySQL performance optimization. What are some of the basic things that you can do uh, when it comes to these databases? So number one is latency, right? We spoke about that when we were talking about challenges and feedback from users in terms of single server offering on open source databases. But it happens with all kind of applications and databases. So it's important to maintain that physical proximity, ensure that your application and database server are in the same region and as much as possible in the same availability zone. So you avoid that unnecessary latency, even if it is of say a few milliseconds or 1 milliseconds. If it can be avoided, your overall performance and hence the experience that your end user will get will be much improved, right? Second is accelerated networking. So something that is available with Azure VMs. If you enable accelerated networking, for example, the benchmarking here shows without having it enabled, the average latency is 1.1 millisecond. But if you enable it, it goes down to zero point 0.7 millisecond. So even a reduction of, let's say 30%, if you look at it in a bigger picture where maybe there are millions of transactions coming up from this application to this database, right? You actually save a lot and you can, really provide a much better experience to your end user, right? Um, okay, dealing with connections, again, something that we have spoken about, but of course, it's one of the most important things. And to be honest, sometimes people, users, customers don't pay enough attention to this, right? It's one of the most important things. Please avoid opening new requests for every connection. As much connection pooling as you can use, it's good for your application. Of course, we are talking about simple applications. If you have an application which always remains connected with the database and always is busy, then possibly connection pool may not give you a huge benefit, right? It is particularly more important for those applications which run simple transactions and quick transactions with the databases, right? You need to make sure that you set timeouts because and at the same time do something to close connection or keep alive that connection. Otherwise, what could happen, like I was earlier saying, is your database could end up dropping the connection while your application will still see that connection, and you will see more and frequent transit failures that we spoke about earlier, right? Um, yeah. So sample, I mean, sorry. Some of the connection pooling that is available with databases, in particular with MySQL and MariaDB. Proxy SQL is quite popular. There are other proxy, other sort of connection poolers also, or even load balancers. But proxy SQL in last few years has really gained popularity and is one of the top ones being used out there, right? It has an inbuilt retry logic. It can also load balance your reads across read replicas. So MySQL and MariaDB are quite heavily used to distribute your reads. If you look at your lot of e-commerce applications or uh, so on, where you have few writes but a lot of reads, let's say in a 20-80% ratio. 80% reads can be served by n number of replicas. So you could have, like 5, 10 replicas serving your reads at the same time. So it's important to load balance these requests across the replicas. So connection pooling also comes in handy if a specific connection pooler can do that, can do the load balancing also. There are some load balancers which can do only load balancing across the replicas, and then there are uh, some sort of load balancers, I would say, which can even detect whether it's a write request or a read request, and accordingly can send it to primary server and read replicas. So, depending on what is it that you want and how you configure your connection pool, all of these make a lot of sense. Improve the overall performance, overall experience with the database by a lot. So some of the blog entries here that you can find as part of the deck after the session, which you can use to refer to, how to set up proxy SQL for these specific use cases. Uh, okay, while not exactly something that you would do in your application, but right sizing the uh, database service for your workload is also important, right? I said burst table is available, but I would not use it for a production workload where I need, a standard performance, right? It's good for those environments where I don't expect full CPU continuously all the time, or I can take some overhead onto performance. So, if it is a production workload where I would expect a specific performance SLAs, even if it is two core, I would go with general purpose instead of burstable, right? While burstable SKU would cost you less, it's not for all kind of use cases, but it's quite good for your development environment, for example, right? Then with general purpose, difference between general purpose and memory optimized largely is with amount of RAM available with or per core, right? So these are different series of VMs which offer almost double the RAM per vCore. So with general purpose, for example, you have 4 GB, and with memory optimized, except for one or two SKUs, you have 8 GB RAM per vCore. This is, by the way, for single server today, because it talks about, if you look at IOPS scaling, it talks about 3 IOPS per GB. With flexible server, what we have done, another learning from the customers, from the users, what we have done is you can now scale IOPS independently of the storage, right? So, for example, let's say a hypothetical case. I'm not saying this is the exact sizing, but let's say you have 100 GB of database. You have provisioned 100 GB of storage for that, and you get 300 IOPS for that by default. Let's assume that's the case. But in flexible server, now you have the option of uh, provisioning additional IOPS. So you can take it to say 5,000 IOPS or 2,000 IOPS for even if it is 100 GB of storage only, right? So it's not necessarily that tightly coupled with storage anymore. But that is something that has come up in flexible server. With single server, which is currently GA, this is what you get, right? Expected latency, as I said, with burstable, it would be variable. There's no, uh, I mean, you should do not expect a lot of, standard performance from burstable because it's not something that is dedicated for you, right? Okay. Now we spoke about skews. Now, what happens when you actually hit some of those upper bounds, some of those upper limits, right? If you hit IOPS, what do you do today with single server? You have to increase the storage because, like I said, single server is uh, tightly coupled with that. Then storage, of course, you need to increase storage. With storage, please keep in mind you should not start with something very big. For example, if you expect 10 GB of data, do not start with say 1 TB. The reason I say that is because storage cannot be scaled down, it can only be scaled up. While with uh, CPU and RAM, etc., with the skew, you can scale it up or down. Storage can only be scaled up. So keep that in mind. Sometimes, in fact, probably something not covered here. I have seen that coming from some of the users in many years actually, and it hasn't changed. So users would say, my database has high RAM utilization but very low CPU utilization, which, to be honest, is not necessarily a bad thing. Why? Because databases are an application where once you configure certain amount of RAM, database will not free it up. For example, let's say in case of MySQL, right? You have something called buffer pool. Database buffer pool. Let's say you've configured it at 100 MB. It will the database will consume that 100 MB as and when you query the data. So it doesn't take up all that amount of RAM when the server starts. But as as more and more data starts filling up in cache, it will consume that 100 MB. But how databases operate is that it will never free up that 100 MB, even if the active area in use is only 1 MB. Okay. It works with least recently used LRU mechanism, which means it will overwrite the least recently used segments, right? But it won't overwrite as long as it can still expand. So, in short, a high RAM utilization is not necessarily a bad thing. It generally means you would actually have lesser CPU utilization because if your cache can serve most of your data, it doesn't need to go to IO. Physical IO is the slowest part of your computer, and that means it utilizes highest number of CPU cycles. So you avoid that by sort of feeding more RAM to your database server. Okay, what happens when you hit higher or upper limits on CPU utilization? Increase the skew. If you are on say 32 cores, go to the next one. Memory utilization being high, while one way of doing this is increasing the skew, but also review your workload. Do you actually, I mean, is your application really doing it uh, optim optimally? It may so happen that uh, uh, well, for example, one query that uh, should return 100 rows ends up touching say 10 million rows. Is that the optimized query that you are running, right? Because if your query touches 10 million rows, it's quite possible that some of that will also come to memory before those final 100 rows can be served to the application, right? So make sure that you don't, right away jump to the conclusion that you need more resources. Also make sure that your application is optimized, right? And of course, keep track of resources using Azure Monitor. And there is a lot of metrics that's available out of the box on Azure. You can also use something like, for example, specifically to MySQL, there is slow query log. You can enable that. Should make sure that you enable it for a very small period of time when you're actually doing the testing. But you can use that. Okay, optimize data access. This is exactly what I was talking about. Fetch only the things that you need. Don't end up, don't avoid any where clauses which can reduce the number of rows that need to be extracted. Have proper indexing, right? Very important. Uh, with proper indexes, you would avoid full table scans, which would mean you touch fewer number of rows and your results are faster and so on, right? Um, I'm sure you know most of this already, but unique index is there for a reason. It can avoid duplicates. It can help improve your where clause performance. So make use of indexes very, very optimally and use as much as possible. Slow query log, as I was mentioning, is there something that can be enabled, but please make sure that you only enable it when you are actually doing some troubleshooting or analysis. Don't keep it enabled because not just the storage it will end up consuming, but there will also be performance overhead because of enabling slow query log, right? For every transaction that you run, rather not transaction, the read transaction that you do on your database will have to be logged, which means there will be performance overhead, right? So use it cautiously, use it, do use it because it offers a lot of details, but use it cautiously. Uh, Last but not the least, there are some basic parameters, right? Like buffer pool size, NODB file per table, query cache that MySQL offers, which has been disabled in recent versions of MySQL because of it's underneath, it has some mutexes that it maintains and how it is not very useful if you have an application which ends up changing data very, very often. But it is still there. It is still very useful for some use cases. If your data does not change very often, query cache can still be used. Uh, what query cache does for if you don't know the use case, what query cache does is it will record your query as well as the result set in memory, right? And as long as your query is exactly the same as you ran previously and result set, if it is something that has not been overwritten, it doesn't even hit the buffer pool, doesn't go to SQL parser or anything like that. It just picks up that data and returns. But of course, every time the data gets changed, this will get invalidated, which means if your data changes often, you are adding many hops. Every time data changes, it will have to invalidate the result. Uh, every time you run the query, it will still check in query cache, will see it is invalid, then go to database and so on. So if your data changes often, do not use query cache. But if there are some use cases where you think it might make sense, do try it out. It could be very useful. Buffer pool size, probably one of the most important parameters in your database. I remember, many years ago, I saw a lot of installations where, users or customers will come to us with performance issues when the buffer pool size by default used to be 8 MB. So even if customer is running a database of say 100 GB, they would not change the default size of buffer pool. So 8 MB of buffer pool, I mean, you can imagine the kind of performance it will give you. Every time a query runs, it invalidates whole of buffer pool, your data loads cannot be served, then you use, uh, maybe sometimes temporary tables, then it goes to on this temporary table. So a lot of mess. Basically, buffer pool size, heap table size, some of the important parameters that you should look at and can be the factor that gives you good performance versus bad performance. I think with that, we come to the end of this session. Again, I would request Vinayak to see if there are any questions at all. We can take them up now.
Sure. I'm just conscious of time, so we have a couple of questions. The first one is regarding the choice of database for like building a first-time analytics or a data warehousing kind of product. What would be the best use case? In your opinion?
Okay. So if you want to stick with open source databases for a warehousing or analytics requirement, I would go with PostgreSQL. To be honest, I mean, that's just my choice. MySQL is very, very good for transactional use cases, but when it comes to large data set, doing analytics on a large data set, I think performance with PostgreSQL is much better. And with Citus or Hyperscale, I think with sharding enabled, I think you can get tremendous benefit when you are doing analytics on top of this data. I hope that helps.
Yeah, it helps. Another common question is like if especially early stage startups, the schema is many times in flux, right? As they kind of do product discovery, market discovery,
Yes.
uh, and that evolves over a period of time. So lots of startups do experiment with MongoDB. But I think with JSON support in Postgres, which I think we talked briefly about, do you think that maybe it can be a good fit for those kind of use cases?
Oh, absolutely. So that's a very, very good question. In fact, I've seen this a lot. People choose a NoSQL database because of this reason, where schema is still under development. But then you sort of get stuck with that NoSQL database because there's no way to do transactions, or it's very, very poor when it comes to transactions and so on. So both of the databases, in fact, MySQL and PostgreSQL, both support JSON today. And if your actual use case requires transactions, requires schema, requires referential integrity, I would go with using JSON in these databases instead of starting with a NoSQL database. NoSQL databases, of course, have their place, are very good at what they do, but again, depending on application, if you actually require an RDBMS, stick with RDBMS. Probably use a JSON data type to start with. Once your schema is more formalized, then maybe convert to a more fixed sort of structure of table. Yes, I hope that helps.
Cool. Thanks, Nitin. And thank you everyone for doing. I think this was a fairly comprehensive introduction to open source database, and we covered a lot of ground and a lot of databases, including database optimization. Hopefully, you will join us in the next edition of Scale Up Thursdays. And with that, I will end this webinar. Uh, thank you, Nitin, for the comprehensive introduction to open source database.
It's been my pleasure. Thank you, Vinayak, for having me. Thank you, everyone. I hope it was worth your time.
Thank you. Bye, everyone. See you in the next webinar.